Until now, my scraping had been confined only to scraping small items and using the surface plate, and I wanted to have a go at doing the bed, scraping the bed of this lathe that I bought. I had previously bought an engineer's straight edge, which was quite reasonably wide, about ½ inch wide and 4 foot long, so it was an adequate length and almost enough thickness to be able to use for printing without having to go to the expense of a very expensive specialised camelback cast iron straight edge. I am very much an amateur at doing this work, and I know that I've used rather too long strokes in the scraping process, but I did follow the ways that I've looked on the internet people have used to layer so that they've got a graduated scraping that is deeper at one end than it is at the middle, which is the process I used. And I'm sure people can find fault with what I've done, but at the end of the day I have produced a bed that is much more accurate than it was at the start, even if it is not perfect. I discovered fairly quickly that it was necessary to have a proper plan of how I was intending to set about the task, and I found the best thing to do for me was to start with the outside V-way, which was the most heavily worn part, and I had a way of getting the correct angle to that V-way using one of the cast iron saddles which came with the lathe, which was very little worn, so I could make sure I'd got the angle reasonably correct. I have seen on YouTube a number of videos that people have done of scraping beds of lathes, and they're mostly simple flat ones like a Myford, which I'm sure I could tackle reasonably easily. But this has complications with the raised V-ways at the front. I wanted to show the whole process from start to finish, including checking the accuracy of it after it was completed. And I've done that now, so I now know what I've managed to achieve. Hand scraping a long surface that is quite substantially out of true takes a long while and a lot of patience. I tried to make sure that the face of the V-way was as flat as it was possible and followed the same angle as the previous V-way. I used cross-hatched layers with more of them towards each end of the lathe. In all, it took me several days to complete, with averaging about 2 days on each surface. It just takes a long time. After having completed the outside V-way, I checked the angle using the saddle and then scraped the inside V-way, which was much less out of true, thankfully, than the outside edge. After that, I needed to check the flat surface was true with the V-ways. Right, now if I slide this up, you can see how much the bubble moves. Not a huge amount. It's more or less on the end of that bar, so it's about 3 millimeters it has moved in total from this side. So that's 1.5 millimeters if you halve it. Not a terrific amount needs to come off. It's perhaps worth just mentioning the way to get these two angles correct was to use a rub on the inside V-ways in this block here, which is, as I said, a reasonably accurate piece of machining that hasn't been altered very much. So I'm happy that when this is done I shall end up with a surface here that doesn't move in relation to these V-ways. And that's the only way I could see to do this accurately. There's a gap between the top of this V-way and the underside here. If you look in here, there's a gap. So it doesn't actually ride on the top of here at all. But if I take this off, you'll see that it was originally machined at the same same flatness as the larger side. So I think when I finish this, I'm happy with this in relation to these ways. I'll then do the top of this just for completeness sake at the same flatness, same plane as that. So a little bit more, I'll come back when I've got that so that the bubble stays nearer the middle. I probably won't get it exactly free from any movement, but we'll see. I'll be back in a minute. An alternative way to measure in this digital era is to use one of these inclinometers, and actually it's surprisingly accurate. I started off and I had 0.03 degrees on this side too high. So if I just push this up here, to be careful not to lift it slightly when I'm doing it. Go back again. Okay, 0.2. It's 0.2 all the way up to there. 0.2 to there. And then it goes on a transition to 0, which is where I set it up on 0, up to the end. So all I have to do now is from the transition point, which is up here, it's about there. There. I need to set that piece down 0.2 of a degree, and I've got an easy way of checking to see when I get to the one. I can check it again with the spirit level, but that's a slightly more visual way of displaying it, and as I say, a cheaper way too. It's a lot cheaper to buy one of those than it is to buy even an old engineer's level. It's now a few hours later, and I finally got this to a point where I'm happy with. I finally got this to a point where I'm happy with it. So that's showing 0.1 on the screen. and 0.1 on the screen at this end. And if I put the bubble on, that has a little more movement, slightly more sensitive. Centralise it. It is centered. Okay. And I think that's probably as good as I can expect to get it. I've still got to make sure that this is flat and angled at the right angle. So I will be taking a bit more off, and I'll try and make sure what I take off is more at this end than this end. This is looking down on top of the tailstock with a test bar which is protruding 11 inches or 28 centimetres out from the chuck, and this is a 3-jaw chuck, and it doesn't displace the bar very much at all, so it's obviously fairly close to being online, and that is, as I say, it's a long way off from the chuck. I'll just turn this on so you can see how accurate the 3-jaw chuck is. You can see that's not wavering around too much at all. So I'm reasonably pleased with that, and I'll now use the test of bringing the tailstock up to the headstock and putting a feeler gauge in. This is looking down on top of the lathe with the two centres together, and this is the usual test to see if this is at right angles to the axis, which this is, and you need to see that it's at the right axis, that's same on the height, so that's right from side to side close up. I'll just tease it off a little bit, and you can, I think I can probably spin it, yes. So I'm quite happy that that is really dead in line. It couldn't be any better. So there's no doubt that that will drill a straight hole through into the chuck. So I'm very pleased with that. It is a little bit off centre at the end, and that's as much due to the slight difference in the way in which the bed is, it's not twisted, but it's riding up slightly on the outside edge, and I think that's what's caused it to not be quite as accurate on the long test bar. But I'm pleased with that now. I set up the test bar between centres at this end and at the tailstock, and this will show you how accurate the top slide is. It's within 0.1 and 0.2 of a millimetre, so I think that's as good as I'm going to get it. And you adjust this obviously by swivelling, and you have to tap it until the minimum amount of movement on a dial indicator is shown. but that should give reasonably good machining. And you don't use the lathe bed in the same way as on a normal lathe, because what you do is you slacken the screw on the bottom of the slide underneath the lathe, and then slide it up, and then you use the top slide again. So really it is not quite irrelevant, but it's not that important, as important that the faces on the ways are absolutely perfect. But anyway, that's where I've got with that, and I'll just show what it is like on the looking it on top of the bed, on top of the test bar. And this is with the dial on the top of the test bar. I'll just run this down a little way just to give an idea as to how much the needle moves.